Hi everyone, my name is Rebecca and I am part of the marketing team over here at Tech 30. I would like to thank everyone for attending this webinar today. We have Cody Wiltrout who will be giving us a live presentation on what's new in Creo 6. And just to remind everyone, if you have a question at any time during this webinar, feel free to leave it in the question or chat box and we will do our best to answer these questions at the end of the webinar. With that being said, I'm going to be passing over the reins to Cody.
Thank you very much, Rebecca, and nice to be here with you all today. My name is Cody Wiltrout, and I'm an application engineer here with PTC. I focus mainly on our CAD and PLM topics, so I'm going to be going through what's new in Creo 6 today and what's changed from the last version. So to start off with the general direction that PTC is really trying to head in with design in general, so we're trying to get to this meeting of the physical and digital environments. And we're doing that in a lot of different ways, but a few to name a point is starting with some of the AR capabilities, being able to use augmented reality directly from Creo for design reviews and being able to explore different options, being able to use simulation-driven design, especially with the new Creo Simulation Live, to be able to do instantaneous simulation and get feedback to test out different ideas and again, kind of help quickly figure out what design options are the best ones, as well as additive manufacturing, which is an up and coming form within manufacturing, and we're trying to meet the needs of our customers as they move into this space as well. And then of course we're always working on increasing the general productivity and usability in Creo. So to start off with just some of the solutions inside of here, we can start with the augmented reality, which we just mentioned. So the augmented reality has been improved for Creo 6. You now get up to 10 models per user. So for those of you who might not be aware of this capability in Creo, under the Tools tab, you have the ability to publish AR experiences. So it takes this model and publishes it to Vuforia Studio or Vuforia View for you, and you can view that using the Vuforia View app that's free on the Microsoft, Apple, and Google Play stores. And then you can view this in 3D space. So it gives you a more interactive way to do design reviews and kind of test out how something might look out in the real space before you build it. And we've now also added the ability to generate QR codes for HoloLens. So if you want to get a little bit more interactive with that even further, you can now use support for HoloLens. You also have control over who can view what. So you choose when you publish it, whether or not it's restricted or public, and who gets to see that. So all of your IP is protected, and it's not even publishing out the true model, just a lightweight representation. Next, on to simulation-driven design. So this gets into kind of that Creo Simulation Live that I talked about. So traditionally, the kind of way design has been done is you start with the concept, do some design work, simulate, prototype, and then manufacture. But realistically, to do simulation, you normally need to consult an expert, and you can't really use the design model. You have to make a simplified version where you've gotten rid of some of the detail. And design's an iterative process. You make more than one design. You go through and repeat on it, and you can't do simulation for every one of them, at least traditionally until now. And so the new vision that PTC has for this is concept and design along with simulation into prototyping and then manufacturing. And the way we do this is through real-time simulation. So this is a new type of simulation that ANSYS developed and has partnered with us to embed into Creo. And it gives every engineer the capability to do fast, easy simulation. So the intent with this is to make sure that it is kind of speed oriented. So it's meant to run very fast, be a very simple setup, easy for engineers and designers to use, not just specialists. And then once you have all of your kind of constraints and load set up, it's going to start running within a few seconds and keep running until you choose to turn it off. And that means that as you make design changes, it's going to update in real time on the displays and the results, what's happening. So you can tell if you're heading in kind of the direction of your goal or further away. And for that, it can do analysis for structural, thermal, and modal analysis, but I will note that it is linear analysis that it's doing. This is available in Creo 6 as well as 5 and 4. And starting in 6 now, they've started being able to leverage mechanism loads, promote part level boundary conditions, and be able to define simulation bodies. So that's some newer capabilities for CSL for anyone who has been using that already. As for usability and productivity increases, starting with some of the basics here, with the mini toolbar, we've expanded it out and its capabilities again. It's now context sensitive, so it knows kind of what you're doing and what the most important options should be based off of where you're clicking. And of course, you can always still configure the pop-up menu there to be whatever you need it to be. So that mini toolbar can be, customized as you want to change it and what's important to you. But it is now context sensitive and understands a little better what you're likely to be doing. With the model tree, there's now a clear indicator between what is active and what is not active in there. So it's made it a little bit clearer for what you're working on. The common filters for the model tree are now also turned on by default. So in the past they were turned off and you had to turn it on when you started the session. Now it will automatically be turned on, and it's been made a little bit easier to save some of those configuration settings as well. For graphing, we've seen just some general improvements with the control over the graph, as well as how you want that to be displayed. So things around the text, color, line options. You have a lot more options now just to format this and make it look the way that you would like to, and make sure that you're meeting your company standards around that. For the user interface, it has been updated, so there's new skins for the dashboards. There's less drop-down lists in the dashboards now and more button options, so they've tried to make it simpler so that you can see all the options as opposed to have to going to a drop-down list to see them. And there's now direct access to the help on the right-hand side of that toolbar. So it's going to have a read more option based off of what you're doing so that you can get more information on that. Sheet metal has also seen some improvements. So it has increased productivity for a faster and more intuitive creation and modification of the walls. And then where the walls come together, we've seen increases in support for corner and reliefs and seams, as well as options around what you want to do with neighboring walls, and new dashboards for the merge and wall command. The volume sweep is something that was introduced, or the helical sweep, in Creo 5. In Creo 6, you can now keep that trajectory as a persistent kind of helical curve, so you can take that out as its own kind of object, where in the past you could see how it was going to move, but you couldn't really get that out as a path or a trajectory. Point projections have been made easier as well, so you can now choose to project onto a feature, and so you can project on a datum point, vertex, or curve endpoint onto a planar surface, datum plane, or straight edge line. So before, you'd have had to set up some mid planes or some lines yourself that you wanted to do to drop that. Now you can just do it automatically. With drill tip angles, it's now been set so that you can set what the default value will be for that tip angle. In the past, you could customize them, you can change them, and you can still change them, I should say. But in the past, you automatically had a preset value based off of PTC standard. Now you can set that preset value based off of your own. With GD&T and model-based definition in general, we've seen some improvements around the context-sensitive formatting ribbons and semantic definition support. So essentially, the things that we've been bringing to GD&T are just being brought over to the note capabilities now. So we're just continuing on with that model-based definition. That is a big driver for us, and we're going to continue to meet new standards and bring improvements with it. In general, there's also now a notification that you can turn on for new maintenance releases. So if you want to be alerted when there is a new maintenance release, you can choose to turn that on. Of course, you're also free to turn that off if you don't want to see them. Rendering Studio has also seen a few improvements. First off, it now has the ability to do emissive appearances. And so what this means is that now when you create a light source with Render Studio, it can be one of the parts or surfaces that you want to emit light, just like the light bulbs in this scene. So you have more control over where the light's going to be coming from, how it's going to be casting shadows, and what objects you're going to be creating it. Along with that, you can now do fully rendered animations using Render Studio. So this is something that Creo could do in the past before we switched to Render Studio, and so now that's a capability again. With detailing, the drawing name can now be extracted from the part or assembly file automatically so that you don't have to do that in a manual process, just saving you a little bit of time, making it a little bit easier. There's also a new configurable background option for the dimension displays, so you can now change what that color on this display is going to be based off of what you would like. Additive manufacturing has seen a lot of improvement in Creo 6, starting off with just some of the different types of lattice structures. The first here is the stochastic lattice type, and this is a randomized beam structure that creates almost like a foam type structure that can be good for reducing sound waves or shock waves and things of that nature, and is just a pretty complex structure in general that you can see here. Creo builds out very fast for you and without you having to go through and try to model that yourself. Along with that, we also now have new formula-driven lattices. The formula-driven lattices are meant to be self-supportive. So for metal printing, they can be printed at a support angle so that they won't use support structures to hold them as much, saving you material and time. These are pretty complex geometries as well. So for the formula-driven lattice types, we currently cannot run simulation for them. For the other lattice types, you can still run simulation, but for the formula-driven ones, they're a little bit too complex for that at the moment, but they do allow you to do that self-supportive lattice structuring to save you time and space. Moving on from there, the last new type of lattice are the custom lattices. So now we give you the ability to build your own lattice. So you build out essentially one lattice cell, and then it will propagate the rest to fill in the shape or the solid based off of what you want. So if there's a lattice type that you want that we haven't gotten around to making yet or that's new and upcoming, you can always model it out yourself and then try it. There's also now been added lattice transitions, so you can transition kind of the spacing between the lattices so that you can increase support in some sections and use less material in others. There's also now build direction analysis, which allows you to determine the optimal way to orient the part inside of the printer to reduce the support material used to print that part. And if you use it early in the design process, it can help determine that lattice orientation that you would like. There's also now new outputs from AMX. The first is a 3MF format, which just has a little bit more information than the classical STL and can provide more better value kind of outputs for other people to use in their printers. And we also now have the CLI output, or the slice file, which goes through layer by layer how you're actually going to be printing that out. Topology optimization along with AMX has also seen some improvements. So you can now optimize a single part based off of where it's at in context of an assembly. And there are now the ability to animate optimization studies along with greater control of the results and how those are viewed, and tools to edit some of the faceted surfaces here with the mesh surfacing. And once you are happy with that facet and you want to do your reconstruction, we've improved that now, made it faster and better, and it's now very easy to be able to go in and change some of those features afterwards using Freestyle. And for your general knowledge, Creo is now on a yearly release cycle with a major release every 3 years. So we're currently on Creo 6 and we'll be going to Creo 7 in 2020, and that will be our next major release. So for your visibility there. I'll go ahead and transfer over to our demonstration for today, and it's going to be focused mainly around the additive manufacturing capabilities, but it is going to show here in the context of Creo 6 and some of those newer capabilities. So to start off with, we're going to be working with this swing arm here from this snowmobile that we're interested in. Now, traditionally, this swing arm here might be a welded part. So we can see we have some weld lines where those are going to be brought together. But maybe we're interested in using some of the newer technology to be able to cut down on some weight on the swing arm. We want to save some material. but we can't just remove a chunk out of it or it won't really function very well. So we're going to replace that with a lattice structure and then compare and see what options or what option is really our better choice here. So we're going to go ahead and open up a new version of that swing arm that we have here, where we've removed some of the material and replaced it with a primitive lattice. So this is one of the lattices that is available back in Creo 4 here that we have in here currently. Now, the base capability of being able to place in these lattices is very similar to how it's worked before. You select the regions or volume that you're interested in, choose the surfaces that you want it to extend out to, and then the type of lattice that you're interested in. So we're going to start taking a look at some of these newer lattice types here, and we'll start with the gyroid. Now you notice as we go through here, you can change the individual cell size for each of these as you need to, as well as the wall thickness or density. So you can get very detailed to the level that you need with those cells individually, and then it will propagate that out and fill in the rest of the space for us. So if we preview what that looks like, we can see with our gyroid that it fills in nicely for us. And if we like this option, we could move forward from here. Now, just to show some of the other new options that we have, we'll go through and take a look at some of the other formula-driven options here just to take a look at them. So if we take over to the primitive, we can see it's going to switch out what that individual cell is, and then as we preview again, it's going to replace all of the old lattice structure there with the new option. So it's very easy at any point to come back through after you've designed it and replace any of those lattice structures. And of course, because you're working in Creo, if you save a tray that has some print options, you can just have that new change pushed directly down to it and update without you having to go through and do a lot of rework around that. So taking a look here at the last new formula-driven lattice, the diamond cell type. From these, we could decide to choose to use any of these if we like them and we're happy with them. In our case, we're actually going to go ahead back to the primitive one just because we want to show some simulation comparisons between the two options. So from here, we can come into one of the other new capabilities, the AR capability. So for those of you who haven't seen this before, you start by just placing a plane, and that tells essentially when you view the augmented reality of that object, how do you want it in orientation to the ground? So in this case, we'd be saying the swing arm is just sitting on the floor. And once you have that placed there, you say you want to publish your model, choose the viewability quality, and so the bigger the model is, the kind of longer that might take to load if you do high resolution, but no real problems there. It just takes a little bit longer to load whenever you view the experience. Once you publish it, it brings you to a web page to be able to manage those. So you can choose whether you want it to be public or restricted and require a password, and choose who you want to share that out with from here. Or if there's any that you want to go back and delete some of the old ones, you can do that. Now, assuming we send this off on a design review and whoever reviews it is happy with the look, they think that's still going to be a fine design for the swing arm, but now we want to maybe start digging a little bit further to make sure that it's what we want. So I'm going to come into our applications here and just choose simulate. And we can see we already have some loads and constraints placed onto here. What's nice with using simulate here with this new version of this model is that we can actually compare this version with the other version directly, side by side, with the same load sets and same constraints to really see if our additive manufacturing option is the better option here. So we're going to start by creating a new analysis and just start picking out what it is that we're interested in seeing and what we want our units to be. Now, when we do this, we can then choose to bring in the original model as well, and we can even tie their orientations together, or if we wanted to tie their legends together, we can do that. Starting at the current model, we can see there are some high stress values at the center bar there, so that could be problematic, but we can open up the results from our other analysis and then do that side-by-side comparison to really see what our best option is. So as I mentioned earlier, we're going to tie these together just so that the orientation is going to be the same, so that we make sure we're looking at the same spot on both. And now if we start zooming in here for these, then we can really get a direct comparison on this kind of what would be weld line on the other to see which is better. And in here we can see we're going to around 570, where on the older version we're hitting at around 607 toward our max. So it is a lower stress value in the additive manufacturing version, and it doesn't look like the lost material is causing any problems. Knowing that, we might now think that this is a great option to move forward with, so we want to start sharing this off or printing it directly from here, and we can do that. We can also do analysis before we print it. So as I mentioned earlier, we might want to know what the best way to place this in the printer is before we start printing it. Make sure that we're using as little support material as possible. And so to do that, we're going to run a build direction analysis or a downscan analysis, and we want to look at our critical and subcritical angles. We can choose to change those if we would like based off of the printer that we're using. And so we are going to go ahead and do that. And it will highlight on the part where you are meeting that subcritical or critical angle. And now based off of those, it can compute what the best kind of orientation is for that to sit in the printer so that you don't have to use a lot of support to hold it up. So it's going to go through and converge on what that orientation is. And when it's done, then we can save this orientation off as its own kind of build direction and use that for the printing process. And as we're going through here, you can see just the general layout and UI with Creo 6 has been cleaned up a little bit. It's a little bit more user-friendly. You can see the changes in the model tree with what's active and what we're doing. Very smooth user interface, easy to pick up and use for moving from past versions of Creo. So now that we have our new build direction, we've basically put in all the upfront work for the print, and now we might want to start exporting this out or printing it. And so we have options around that. We can either save a file and we can do things like STLs or that new 3MF format, or we can print directly from Creo. So we're going to start off with a 3MF file just to show what that kind of export looks like, and we'll take a look at it here in a moment. And the other option here after the save is that we could just print directly from Creo. So you can connect up to those printers, choose how you want it to be brought in, what the scale is going to be. In our case, we're going to be using that build direction that we already had created. So we'll just choose that build direction, place it in. If we wanted to do more, we could assemble more in. We could pattern it if there's going to be printing a lot of them. And you can change between which printers you're using. If you have plastic and metal printers, choose which one it is that you want to be using. And of course, you can always edit any details for it as well, like in our case, that self-supporting angle that we had changed for our downscan analysis, we'll use that. Now that we've done that, we can generate the support, and it does that using Magic's SG kernel and goes through and builds out that support structure for you automatically. So saves you time, makes it easy. Now that we're happy with that, we can choose the printer that we want. We chose a metal printer in this case, so we can validate that it's going to fit in the printer. Everything looks good. We're happy with that. So we know it's going to fit, but now maybe we want to get a step further and look at how it's going to go through layer by layer and print that. So we'll just get this slice file here. It'll go through and start by just generating the slice file. And after it has generated it, then you can come back up and choose to view it and display those slices. And then you can choose to either pick a specific slice or just let it play through all of them. And so here we can see as the printer would go through, this is the method that it would take to print out this part. And of course, you can export that out and share it with someone as well if they would need it. Lastly here, now that we have this and we're happy with it, we can save that print job, save that tray. As I mentioned, if you do an update, you can push it down so that you don't have to do any rework. And if we look at that 3MF formatted file that we've created, we can see that it does actually store a lot of metadata with it, including color and some orientation information. So pretty nice file format there to be able to show people. So that is kind of the what's new in Creo 6 and the new capabilities from the new extensions and some of the extensions that have seen improvements to those base user functionality improvements, as well as what our releases are going to be looking forward. So thank you very much for your time, and if there's any questions, I'll go ahead and answer them now.
Thank you, Cody. We actually have one question from Bethany Runyon, and their question is, what output options do you have for additive manufacturing?
Yeah, so as we had touched a little bit on the demo there, there's a few different options. Newer is the 3MF format, which is one of your best options for being able to get extra metadata. The slice file is an output option that is a little bit more analytic and goes through layer by layer how it's going to be building that process out. And then, of course, you have your more classic files like STL files if you just want something that's going to be a tessellated model that someone can print from. You can always use that as well.
Okay, thank you. And there's one more question, and it is there a general recommendation for managing the native design file?
So I guess it depends. There are different options with Creo. For one thing, you can use design exploration, which is an extension that allows you to create different checkpoints and save different design versions all in one model file. So that can kind of cut down on managing that data by allowing you to keep different designs all tied together. Past that, then it gets into a question of managing maybe using PDM or PLM if you're trying to work with a large team and make sure that they're following the correct kind of processes to make sure that people aren't overwriting each other or anything of that nature. But otherwise, if you're just using Creo, there's not really any additional kind of things you need to do to keep the files. But best practice-wise, I would say design exploration can be very helpful if you feel like you're getting a lot of save as files or spin-off files just to explore different design ideas. It can really help to consolidate that down.
Great, thank you. Looks like there are no more questions. So just as a reminder, I highly encourage you to subscribe to our YouTube channel as we have previous Creo, MathCAD, and Windchill webinars and tutorials. Follow us on LinkedIn, Facebook, and Twitter as well to be updated on any upcoming events, webinars, and exclusive deals from PTC. Once again, thank you all for attending and have a great rest of your day.
Thanks, everyone.